Hello students, good morning. See, in a previous video we have seen the information about the Newton's first law of motion. See, what is the Newton's first law of motion? The Newton's first law of motion is all about Newton's law of inertia. See, Newton's first law of motion is also known as law of inertia, and all of you know that what is mean by inertia. The property of object remains as it is. If the object is a steady, it is remain as it is. If the object in a motion, it is remain as it is. This property of object is known as inertia, and the first law of motion is all about the law of inertia or the property of substance. The first law of motion is depend on the property of substance, that is nothing but the inertia. Therefore, Newton's first law of motion is known as law of inertia. See, in this video we are going to learning the second law of motion or Newton's second law of motion, that is nothing but the law of momentum. See, what is the name or the law, what is the law? Law of momentum. Law of momentum. Newton's first law. See, you have question in exam. Newton's the first law of motion is known as dash dash. You must write there the law of inertia. And what is the second law? The second law of motion is law of momentum. See, then what is mean by momentum? See, momentum is nothing but it is. See, if you consider if I consider the object, it is in a motion. Every object which is having motion or which is in a motion, particular having mass and velocity. The object having particular mass and velocity, the product of mass and velocity is nothing but the momentum. What I say? The object, the product of mass and velocity is known as momentum. Therefore, I will write here the momentum is nothing but P is equal to, momentum is denoted by letter P, and the momentum P is equal to m into v, that is nothing but the mass and velocity. Consider any object which is in a motion, that each object having a particular velocity and mass. Newton said about these two quantities, the relation between two quantities, he was said that the product of mass and velocity is nothing but the momentum. See, then it is multiplication of mass and velocity. See, then definition we have seen. What is mean by momentum? Momentum is nothing but it is a product of mass and velocity. See, then what is the unit for momentum? See, it is a product of mass and velocity. Velocity is the vector quantity. Therefore, momentum is also vector quantity. Then what are the units for momentum? See how the calculation of unit takes place. See, based on this equation. See, momentum is a vector quantity because it is depend on these two factors, and velocity is a vector quantity. Therefore, momentum is also vector quantity. See, I will show you the SI unit for momentum, or I will write here the SI unit for momentum. See, what is the momentum? Momentum is nothing but P is equal to mv, that is nothing but P stands for momentum, m stands for mass, v stands for velocity. See, what is the mass, what is the unit of mass? That is nothing but kilogram, grams. We will see here the SI unit. Therefore, I write here kilograms. And what is the unit for velocity? The unit for velocity is mass per second. Okay, therefore the SI unit of momentum is kilogram into meter per second. Sorry, not mass per second, meter per second. This is the first unit. Then what is the CGS unit for? CGS unit for momentum. CGS unit for momentum. What will be changed here? See, here is the kilogram, here is the gram, and into meter per second. Here is the centimeter per second. These two are the units for momentum. See, the Newton's second law is known as law of momentum. And what is the momentum? Momentum is nothing but it is product of mass and velocity. Then what is the statement for the Newton's second law of momentum? See, statement is a very easy. Statement of Newton's second law is rate of change of momentum. Rate of change of momentum is directly proportional to force. Is directly proportional to force, and the change in momentum is in the direction of force. In the direction of force. This is the statement for the Newton's second law of motion. All of you getting this? What is mean by momentum? Here is the statement for Newton's second law. What is the statement? Rate of change of momentum is directly proportional to force. Rate of change of momentum. I will write here. Rate of change of momentum is directly proportional to force. See, this is the statement. Okay, consider a object moving with a mass m and initial velocity u. See, consider a object having mass, okay, having a particular mass and moving with the initial velocity. What is the initial velocity? U. When we applied force on that object, see what I say, a object, consider a object which moving with a mass m, which having initial velocity u. When we applied an external force on that object, what will change here occur? The change in a velocity of that particular object. What change occur here? The velocity changes to u, okay, in a particular time period t. Okay, understood? This is the momentum. Okay, then what will be the initial momentum? Based on this equation, the initial momentum is equal to, see, what is momentum? Momentum is the product of mass and velocity. Therefore, I can write here the initial momentum based on this consideration. Initial momentum is equal to mu. Okay. Then what is the final momentum? Final momentum is equal to mv. Okay. Now we are going to calculate the rate of change of momentum. See, here we get two values. Values for what? Values for initial momentum and final momentum. See, now what is the rate of change of momentum? Rate of change of momentum is nothing but rate of change of momentum is nothing but initial momentum. See, sorry, not initial momentum, final momentum. Why? Because final velocity is always greater than initial velocity. All of you know that. We have already studied in concept of acceleration. Okay, so what is the formula for rate of change of momentum? Is equal to final momentum minus initial momentum divided by time. Why I take here time? Because this rate of change occur in a particular time period. Therefore, what will be the formula here? The rate of change of momentum is equal to final momentum minus initial momentum divided by time. Then what is the values? What is the final momentum? Final momentum mv minus initial momentum mu divided by t, okay, or time. I will take m here as a common because both sides having m. Then what will be the equation? V minus u divided by t, and all of you know that v minus u is nothing but, what is v minus u is nothing but acceleration. Acceleration is equal to v minus u divided by t. Therefore, I can write here m into a, okay. I can write here m into a because what is the value of a? Value of a is v minus u divided by t, okay. Then what is the rate of change of momentum? Rate of change of momentum is nothing but applied force. When will be the change in momentum occur? When external force is applied. Therefore, I can write here F into, okay, F into ma. See, we will get the equation F is directly proportional to ma. See, I can write here F is equal to K into ma. K is nothing but proportionality constant, and this is nothing but the Newton's second law of motion. What will we get? What will we get here? F is equal to K into ma. K is a constant, therefore F is equal to ma. Okay. This is the Newton's second law of motion. What is the statement? The rate of change of momentum is directly proportional to force. We will stop here.